Hello, this is Mr. Henry, and welcome to lesson 2.2. This lesson is all about adding numbers. We'll be adding positives, adding negatives, adding fractions, adding decimals. By this point, you should have a good understanding of how to do each of those. This is a review lesson. This is not to teach you how to do something for the first time. I will be going in detail with the first few problems, but after that, we'll be picking up the pace and going a little bit quicker. So if you need to go back and review some of those other details, make sure you do that. Okay? So the essential question is, how do I add positive and negative numbers? That's really the core here, is talking about the positives and negatives. You should know how to do fractions and decimals. So here we have 4, get the goofs. I have, number 1 is adding 1 plus 3. Does that equal 4? I sure hope so. That one's good. Number 2, 5 minus 2. Well, it's not 7, it's 3. 1/5 plus 1/2 is not 2/7. When you add fractions, you do not just add the top numbers and add the bottom numbers. You must find a common denominator, something that both 5 and 2 go into. Then you multiply each fraction. So I'm going to multiply this fraction times by 5, because 2 times 5 is 10. 1 times 5 is 5. This side, 5 times 2 is 10, and 1 times 2 is 2. Then you can add them up, and you get 7/10. And lastly, number 4 does not look right. I would probably do the subtraction up and down. So I'd take 8.8 minus 0.9. Remember, when you're adding and subtracting decimals, the decimals have to be lined up. And then the rest of the problem, you just do normal subtraction. You cannot take 9 away from 8. So you borrow, he goes to 7, he's 18, he's 9, 7.9 is our answer. Okay? So decimals have to be lined up. Fractions, you have to find a common denominator. And whole numbers, you know what to do there. Now, let's get to it. We've got 2 vocab words here today. We've got additive identity and additive inverse. These are a couple properties that will come up periodically throughout the lesson or throughout the chapter. So the additive identity is the sum of a number and 0 is the number, meaning the additive identity is this number 0. It's basically 3 plus what number gives you 3, and that number is 0. So 0 is called the additive identity. But this is what the property looks like. The other property is the additive inverse. It basically is kind of like that. It says the sum of a number and its opposite is 0. So 5 plus what equals 0? And the answer would be a negative 5. So the additive inverse are 2 numbers whose are opposites of each other. Doesn't have to be 5. It could be a negative 19 plus a positive 19 equals 0. The numbers are opposites of each other. Okay? That's additive inverse. By the way, in this chapter, you will find a large variety of different properties we're going to talk about. The whole point of those properties is it gives you some little shortcuts on how to do some math that we would normally have to do a long way. Now, here we have a little grid box. This is still in our vocabulary box here. This is how I remember my integer rules. I make this little chart. Now, actually, when I do it on a piece of paper, I actually make mine look like a tic-tac-toe board. So I just go and then here I put signs the same and signs different, plus, multiply, or divide. So this is what mine looks like. This is just another way of writing it out. So I make mine look like a tic-tac-toe board, and then I fill in what I need. I'm going to go ahead and fill in two of the pieces today. Because we're talking about addition, we'll fill in the addition column here. And then we'll use them in the problems after this, and we'll see how they work out. So, when you are adding two numbers, if the numbers have the same sign, meaning they're both positive or they're both negative, you add the numbers together. So 1 plus 3 is 4. Negative 1 plus negative 3 is a negative 4. If the signs are the same, you add. If the signs are different, you subtract. I don't care that there's a plus sign in the problem. If it says negative 3 plus 2, I don't care there's a plus sign. What really matters here is that there's a plus sign and the signs are different, so you're going to subtract, and in that problem would give us a negative 1. So if the signs are the same, you add, signs are different, subtract, and then I'm going to do the abbreviation and then I'll write it out. Kasibatan. This stands for, and I'm going to write it a little bit prettier, keep the sign of the bigger number. So for example here, negative 3 or negative 2, there are more negatives than positive, so the answer is negative. You kept the sign of the bigger number. This stands for keep, oh my goodness, I can't write today. Keep the sign of the bigger number. That's what this stands for. Keep the sign of the bigger number. That's how you know whether your answer is positive or negative when you do addition. Okay? So you have this written down. You may not completely understand it, or you might because you did it last year in pre-algebra, you did it the year before in course 2. So you've done this integer stuff for a couple years now. It should be familiar. But if not, let's do some practice problems. So we're talking about addition here. So I look at these two numbers, and their signs are different. One is positive, one is negative. So the signs are different, so I'm going to subtract. 5 minus 4 is 1. And then I keep the sign of the bigger number. There are more negatives, so the answer is negative. Boom. Done. Letter B. I look at my two numbers, and the signs are the same. They're both negative. The signs are the same, which means I'm going to add. 8 plus 7 is 15. And then I keep the sign of the bigger number, which is a negative. See? Bigger number, negative, answer, negative. Negative 15. Done. That's how quick these problems really are. Letter C. My signs are the same, so I'm going to add. Keep the sign of the bigger number, positive, positive. Done. Lastly, letter D. My signs are different. One's positive, one's negative. So I'm going to subtract, and then I keep the sign of the bigger number. I got a positive 3 for an answer. So you look at the numbers. If the signs are the same, you add. If the signs are different, you subtract. You keep the sign of the bigger number. Sounds simple enough? Well, here's 2 for you to try. Please do letters E and F right now. Pause the video, do it on your own. When you're ready to continue, hit play, although you're probably already almost done. Okay, letter E. Signs are different, so we subtract and keep the sign of the bigger number, negative 3. Signs are the same, so we add. Well, well, same, different. Signs are different, I guess. I mean, 0 plus anything, it's going to be that number again. I mean, 0 plus anything is itself. But I guess you say signs are different, subtract, keep the sign of the bigger number. Whatever you want to do, it's 2. 1, 2, 3, 4. Do these 4 more problems right now, please. Okay, if you haven't done the 4 problems and finished them yet, pause the video and do them on your own. But let's go through them. Letter G. The signs are the same, so we add and keep the sign of the bigger number, so it's a negative. Signs are the same, so we add, keep the sign of the bigger number, it's negative. Whoa, now we got 3 numbers. So order of operations says we work from left to right. So 9 plus 4 is 13. And 13 plus negative 2, the signs are different, so we subtract. Keep the sign of the bigger number, so it's a positive 11. Letter J. Order of operations, left to right. Negative 12 plus 3, the signs are different, so we subtract. Keep the sign of the bigger number. And the signs are different, so we subtract. Keep the sign of the bigger number. And that's it. That is our integers. Yeah, that's our integers. Positives, negatives. That's how we add. If the signs are the same, you add. If the signs are different, you subtract. Keep the sign of the bigger number. Okay? Now, what we're going to get into next is a little bit harder, because now we're not talking about just integers, just whole numbers. Now we're going to get into fractions and decimals and mixing fractions and decimals and whole numbers and all kinds of garbage that's going to get a little bit uglier. This is where your prior knowledge, hopefully, comes in handy. So, letter A. I look at the 2 numbers. They have the same sign. They're both negative. So I'm going to add them together. So I take my 8.4 plus 0.7. Decimals are lined up. And now I add. 4 plus 7 is 11. 8 plus 1 is 9. Keep the sign of the bigger number negative. So I get a negative 9.1. With decimals, you line up the decimals, then add like normal, or subtract if you need to, and then put down the correct sign with your answer. Letter B. When you're adding fractions, you must have the same denominator. Well, 3 and 5 are not the same. So, I find out what numbers, I find multiples of 5 until I find one that 3 goes into. So does 3 go into 5? No. Does 3 go into 15? I'm sorry, 3 go into 10? No. 3 go into 15? Yeah. So 15 is my least common denominator. This whole fraction, if we get to 5 to 15, I'm going to take times by 3. So 2 times 3 is 6. Don't forget your negative sign. This whole fraction, to get from 3 to 15, I have to take times by 5. So my new top number, 1 times 5, is 5. And now we have 2 fractions with the same denominator. We can do the math. So my signs are different. So you subtract. 6 minus 5 is 1. Keep the sign of the bigger number. Negative. There's more negatives than positives. Letter C. I do not have 2 fractions. I have 1 fraction and 1 mixed number. So the first thing I'm going to do is I'm going to change this mixed number into a fraction. 4 times 3 is 12, plus 1 is 13/4. Now, I have 2 fractions, but they do not have the same denominator. Well, if you count by 8s, the first number that 4 goes into is 8. 8 is the least common denominator. So this guy, I don't have to change at all. I'll take times by 1. This guy, I have to take times by 2 because 4 times 2 is 8. 13 times 2 is 26. My signs are the same, so I add the numerator, keep the denominator, gives me 38 over 8. We can't leave it like this because it's a mixed number. So we change it back. I'm sorry, it's an improper fraction. So we change it back into a mixed number. 8 divides into 38 4 times. Because 8 times 4 is 32. 8 times 4 is 32. So I need to add 6 more to get to 38. 8 times 4 is 32, plus 6 is 38. And the very last thing is simply just reducing this a little bit. So 4 and 6 over 8 simplifies to 3 over 4. So a bit longer problem? Yeah, that was a bit longer. We had to find a common denominator. We had to change that first mixed number into an improper fraction. There's a common denominator. Add it up, change it back into a mixed number, simplify the mixed number. Fractions are definitely harder. They take more time, more space, but you should still know how to do them. You're not going to have to do them a lot throughout the school year, but you should not forget them. Letter D. My signs are different. I have to subtract. Well, I've got decimals. So 5 minus 1.2. Notice how I have my decimals lined up. This would be a 5.0, because that's 5 is a whole number. To do my subtraction, I would have to borrow, because I can't take 2 from 0, so that goes down to a 4. He goes to a 10, which makes this an 8 point, and 4 minus 1 is 3. So I've got 3.8 now. Sign. The bigger number is positive, answer's positive. So I got a positive 3.8. So not only do you have to pay attention to the decimal math or the fraction math, you also have to pay attention to the signs. This is the most computationally hard chapter. The math itself, if you had a calculator, would be very simple. The steps are easy, but it's doing all of the math and making sure you're getting all the steps correct that's hard. I would like you to please do E, F, G, and H. Pause the video, do them right now, and then we'll go through them together when you're ready. Alright, letter E. We've got decimals. The signs are different. So we're going to subtract. So I still set it up with a bigger number on the top, 1.34. I'm subtracting. You need to add a 0 here because you can't take 4 away from nothing. So you borrow, and 4, and decimals stay lined up, and 2. And now you have to keep the sign of the bigger number. Well, the bigger number is positive, so the answer is positive. Letter F. My signs are the same, so we're going to add. Now, to add, you have to have the same denominator. So you got to figure out, what does 4 and 5, what number do they both go into? If you don't know it off the top of your head, you can look at a multiplication chart, or you can count by 5s till you find a number that 4 goes into. And that's it. 5 goes into 20, 4 goes into 20. So that is going to be your common denominator. To get to 20, this fraction we're going to take times by 4. So the top number times by 4 is 16. The bottom number times by 4 is 20. And don't forget your negative. This whole fraction we're going to take times by 5, because 5 times 4 is 20. The top number times by 5 is 5. And don't forget your negative. Now we have the same denominator. We can do our math. So we said we're going to add because the signs are the same. So 16 plus 5 is 21 negative. And this is a improper fraction because the top number is bigger than the bottom. So we change it back into a mixed number by dividing. 20 goes into 21 one time. 20 times 1 is 20, plus 1 gives us 21, and don't forget your negative sign. So negative 1 and 1/20. Letter G is a little bit simpler because we got decimals again. Both numbers are positive, so the signs are the same. We're going to add. So we just line it up. 8.9, 3.5. I like the bigger number up top. Add them up. Decimals stay lined up. 9 plus 5 is 14. 8, 9, 10, 11, 12. 0.4 is done. Super easy problem. Lastly, letter H. We have different denominators. Common denominator, you count by the bigger number until you find one the bottom one goes into. Does 2 go into 6? Yes. 6 is the common denominator. So this guy does not change. It stays 9 over 6. This one, we have to take times by 3, because 2 times 3 is 6. 1 times 3 is 3, and don't forget your negative. These signs are different, so we are subtracting. So when you subtract, you take the bigger number minus the smaller. So 9 minus 3 is 6. Keep the sign of the bigger number. That's this. Positive. And then simplify. 6 divided by 6 is 1. And we're done. Hopefully you had some success. Hopefully, definitely with the decimals. With the fractions, I also hope you had some success there as well. If you did, then you're in good shape for the rest of the year. If you are really struggling with these fraction problems, then you need to take some time and go look at some more resources on fraction, addition, and subtraction. Now, the next thing we got here is a couple of properties. So we're just going to identify these properties of addition. The whole point of these properties is it allows you to do math easier. You do not always have to follow the order of operations because of some of these other properties that tell you can modify the rules a little bit. So let's just name these guys. Letter A here. This is known as, well, it's known as the commutative property of addition. Let me get my spelling all right. So it's the commutative property of addition, also known as the moving property. Because if you look at these two sides of this problem, all that really did is we switched the y and the 9. We moved them around. That's what the commutative property of addition says. It says if you have only addition, or if you have addition between two numbers, you can switch those numbers around and it does not change your answer. So that makes it a little bit easier because now if we were trying to do this problem, we could add the 3 plus the 9 together and get 12. And we'd have like a 12 plus y, which is a little bit prettier than saying 3 plus 9 plus y. Letter B. We saw this up in the vocabulary. This is an example of the additive identity. Where you have the number plus 0 gives you that same number back. That's the additive identity. Letter C. This is known as the associative property of addition. This is also known as the grouping property because you're changing how the parentheses are. You're changing the grouping. So in this original problem, you'd have to add the a plus b first because that's what's in parentheses. Get that your answer, and then add c. Well, because it's all addition, you can change it to say, no, I want to add the b and c first, then add a. So it changes the grouping around a little bit. It's known as the associative property. And letter D was also in the vocabulary box. This is the additive inverse. Where you have two numbers that are opposites of each other being added together, and the answer is 0. Okay, so those properties will come up. You'll see the same properties when we get to multiplication. I mean, there's a multiplicative identity, there's the commutative property of multiplication, associative property of multiplication, but those properties do not exist for subtract or divide. Well, there's the identity property, but there's no commutative property of subtraction. Because if you take two numbers that you're subtracting, say 5 minus 3, if you switch those numbers around, you do not get the same answer. It works if you're adding, it does not work if you're subtracting. The same thing is true with divide. If you switch the numbers around when you're dividing, you don't get the same number. 4 divided by 2 is not the same thing as 2 divided by 4. Okay? So these properties, again, are to help you do math a little bit simpler. And I think we've got 2 word problems, a couple problems from the textbook, and we're done. So let's check these out. Example 4, solving a multi-step problem. It says, Jamie kept track of the temperature each Sunday for 1 month. The temperatures, and temperatures is spelled wrong, T-E-M-P, the temperatures were -12, 5, 24, and -1. What was the average temperature? So the thing it wants us to figure out is, what is the average temperature? So the first thing I'm thinking in my head is, okay, to find the average of something, you add them all up, and then you divide by the number of numbers. Okay, so we've got to add these all up and then divide by how many numbers there are. So we're going to take -12 plus 5 plus 24 plus a -1. Okay. Now, I'm going to show you a little trick. Instead of adding straight across, I'm going to use this commutative property. I'm going to move this -12 back here. Because what I want is I want to have my positive numbers together and my negative numbers together. So watch what happens when we do this. If I rewrite this now as 5 plus 24 plus negative 1 plus a negative 12. Now check this math out. 5 plus 24 is 29. Now I can add my negative numbers together. The signs are the same, so I'd add and get a negative 13. And then just add these two together. It's a lot easier than going, okay, this plus this one's a negative, then that negative plus this thing's going to, I'm going to subtract and get a positive, and then that thing plus this thing, the signs are different, I have to subtract, and it just makes it much easier if you add all the positives together, add the negatives together, and then do that math. So 29 plus a negative 13, the signs are different, so we're going to have to subtract. Keep the sign of the bigger number. And then divide. So we added them all up, we got 16. Now we take that number and divide by the number of numbers. Well, there's 1, 2, 3, 4 Sundays she recorded. So you take 16 divided by 4, you get 4. So the average temperature was 4 degrees. Must be like January, some month that's really cold. But the average temperature was 4 degrees. Okay? Last of these problems. It says 2 friends weighed themselves each month to see who could lose the most weight. Dieter A's weights each month were negative 3.3, negative 5.1, and 0.5 pounds. Dieter B's weights each month were negative 7.8 plus 2.1, negative 0.8. Which dieter had the greater weight loss? What I'd like you to do is I'd like you to make an attempt at the problem. Pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so for dieter A, we had negative 3.3 plus a negative 5.1 plus a 0.5. And we want to add these together. So let's add these together first. We get the signs are the same. I'm adding my negatives together. I get a negative 8.4 plus 0.5. The signs are different, so I have to subtract. And I'm going to get a negative 7.9. Don't believe me? Negative 8.4, 0.5, have to borrow. That's a 9, that's a point, that's a 7. Told you. Alright, letter A. So dieter A lost 7.9 pounds. Dieter B, let's see, 7.8, that's a negative, plus 1.2, plus a negative 0.8. So let's see. If we add the negatives together first, so negative 7.8 plus negative 0.8 gives me a negative 8.6. Negative 7.8 plus negative 0.8. 8 plus 8 is 16. Carry the 1. 7 plus 1 is 8. Decimals lined up. There's our negative 8.6. Now, 8.6 plus 1.2, the signs are different, so we have to subtract. 8.6 minus 1.2, 4.7. 7.4, and you keep the sign of the bigger number, so it's a negative. So dieter A lost 7.9 pounds. Dieter B lost 7.4 pounds. So which dieter had the greater weight loss? Which one lost the most weight? Dieter A. This one lost 7.9 pounds. This one only lost 7.4. So dieter A lost more weight. These are the last problems for the day. So they come from pages 74 through 76 of your textbook, numbers 1 through 10. Please pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, so let's see here. Numbers 1 through 4 are a little bit easier. The signs are different, so you subtract, keep the sign of the bigger number. Done. Signs are different, subtract, keep the sign of the bigger number, negative. Signs are different, subtract, keep the sign of the bigger number, negative. Signs are the same, add, keep the sign of the bigger number, negative. Those 4 were easy. Okay, number 5, we've got decimals. So we're going to line up the decimals. I'm going to put the bigger number on top, and there goes me messing up with my writing again. 6.7, 0.6. Decimals are lined up. The signs are the same. They're both negative. So we're going to add the numbers together. And that gives me 13, and that gives me 7. So 7.3, and you keep the sign of the bigger number. So it's a negative 7.3. Decimals, so you line up the decimals. I'm going to put the bigger number on top. Decimals are lined up. This one's negative, so the signs are different. So we're going to subtract. 2 minus 1 is 1, 6 minus 0 is 6, and 1 minus 1 is 0. Keep the sign of the bigger number. That is a negative 6.1. We've got decimals, so we're going to line up the decimals. I'll put the big number up top, 8.7. The signs are different, so we have to subtract. 1 minus 7 we can't do, so we borrow. 3 goes down to a 2, 11, 4, decimal. 2 minus 8 we can't do. 12 minus 8 is 4, though. And keep the sign of the bigger number, which is negative. So that was 5 through 7. And lastly, 8 through 10 is just identify the property, number 8. That is the additive inverse. I know because these two numbers are inverses of each other, and they're being added together. Number 9 is the additive identity. Because it's plus 0. And number 10 is the commutative property of addition. And I know because the numbers are moving around from their original positions. So, what are the rules for adding positive and negative numbers? In your own words, if you can do it without looking back to the beginning, even better. What are the rules for adding positive and negative numbers? Go ahead and write your answer. If you don't, hit play when you're ready to continue. Okay, here's what I have. I put down if the signs are the same, add. If the signs are different, subtract. And keep the sign of the bigger number. That is the verbal way of saying this chart. Signs the same, add. Signs different, subtract. Keep the sign of the bigger number. And the homework comes from page 67, numbers 2 through 16 evens, 22 through 30 evens, 38 through 40 evens. So it looks like a lot, but it's not because there's just the even numbers. So there's like maybe 12 problems there, 15 problems maybe. All right. This has been lesson 2.2. Thank you for watching.